consolidated into what's called a function.
Okay.
And that's what the point of these are. So defining function, right?
Mm-hmm.
You can name the function whatever you want. This is the name of the function. We called it foo for
Right.
no good reason.
Mm-hmm.
Actually, let's make it relevant. Let's rebuild the temperature testing. So void test temp. And it's totally up to you how you name it. Depending on your language, there's different conventions. Usually in C, people use the underscore convention. So they'll write a word in lowercase, put an underscore, and write another word. But I don't like it. I think it kind of looks ugly. So this is called Camelback notation. You start off with the lowercase, and you capitalize every next word. It just makes it more readable.
Every next word.
Yeah.
Test temp.
Test temp. So see, it starts out lowercase, and then we capitalize the next one. So if we added another word onto the end of the name of our function, we would capitalize it.
Hmm.
So it's kind of like a camel.
But still has a name.
Yeah, it still has a name.
All right.
It
So,
really doesn't matter how you name it. Well, it kind of does, but
with the parentheses, does that mean anything?
yes, it does. But we'll start over here.
Okay.
A function can accept data, and it can return data. Those are the two things a function can do. And that's what these two things here are for.
Void in parentheses or function?
This specifies what we're returning from the function. So let's say inside of here, I made a variable. I made wasteful. Byte. Byte A is equal to 7. And I change this from void to int. Now, I'll change to byte. Return A. Okay. So what this word up here specifies is what we're returning from the function. It says byte, so that means we know this function is going to return a byte every single time. It has to.
Then how big is void then? Just one question.
Void is nothing. It's a data type we didn't actually cover. Void is equal to null. It's empty. It's just another way to express 0. And use it mostly, well, the only time you'll be using it is in your function headers. This is called the header right here. So byte, this term right here specifies what our function is going to be returning. So we made a byte right here, and we said return A, return this. And what the return statement does is say I come down here into my main loop, void loop. And I create a byte variable, and I set it equal to this function. What it's going to do is, it's going to read this and say, okay, you're calling a function. It's going to come up here to this function, and it's going to start executing this line by line. So it reads, okay, we're creating a byte, put the number 7 in it, and then we're going to return it. So really what this is doing is, because this returns a type, this is going to consolidate. It's going to be evaluated, and it's going to turn into a 7, because that's what we're returning. So this, if we were to print it, is going to be 7 as well, because it returned that type. The most important thing to remember, though, is that because this is a byte, if I were to make this an int, you'd get a compile error, because you can't return a different type. You have to specify the type up here, and it has to match with the type that you're returning.
So it wouldn't work, right?
This would not work, no.
So you have to change it back to byte.
Mm-hmm. Now, you don't necessarily have to return something. If you want to define a function that just does something and doesn't return a value, up here, you put void, which is what you see down here in our loop. Our loop program is the one that, our loop function is the one that loops over and over and over again an infinite number of times, so there's really no need for it to return a value, because it's never going to end. It's never going to exit. So that's why they used void in the declaration of the function, because it's not returning anything. So down here, we don't need this return, because this is void now, and it's not going to do anything. It's not going to return anything. So
Okay.
that's kind of how you return values. And again, since it's void, we don't need to set it equal to anything. We can just call the function and It's going to come up here and start executing it line by line. Now, that is returning arguments. We can make that anything. We can make it an int, a short, long, a float, double, char, whatever you want. Just make sure you're returning that type or else you'll get an error. Okay, so we'll just go ahead and make this byte again. And we'll talk about receiving parameters. So inside the parentheses, what you can do is you can specify a number of items that you can plug into the function, and they'll operate based on those values. So this is probably not the best example, test 10. We'll just go back to foo. Foo. Okay. And it's going to take a number of parameters. Let's make it just one for now. So we're going to specify int a, open bracket. Okay. And down here, we'll just use ints. We'll say int, we'll call it x, equal to foo, and I can pass in the value. Now, this is kind of a pointless function, but just so you can see how this works, what's going to happen is we're always going to start with our loop. This is our main entry pointer for the program, and we're going to create a variable, and inside we're going to assign whatever this function returns. So it's going to come up here, int foo, and it takes in a parameter. What this value is going to be, A, it's going to be the number you plug into the parentheses down here when you call the function. So every time we reference the letter A inside the body of the function, it's going to pretty much be equivalent to 8. Now we could in here say A++, and then that's going to add 1 to the 8, right? And then it's going to return it. It's going to change it to 9 after it's added. It's going to return the value 9, and that's going to be assigned to x.
Oh, okay, so it's going to change always over time. Right? Correct?
Change over time.
No, once you start that thing, it's going to start changing it from 8 to up. Right?
This is only going to execute once. Well, technically you're right, actually, because it is going to run this code over and over and over again. However, when it does it, every single time we're still passing an 8. So it's not going to keep going up and up and up and up. It's just going to be a 9 every single time. Because first time we're doing it, we're passing an 8. The 8 becomes a 9, and we return the 9. Down back here, and up again.
Where's the A returns the A to?
Where does it return to?
Yeah?
This is kind of what the function gets evaluated to. So when we call it down here, once this function gets called and it executes every single line, we return the A. This A becomes, instead of foo8, it becomes 9, the value we returned. So the return value goes back here to where we originally called it.
Alright. And so it's not foo8, it's not foo parentheses 8 anymore, it's just 9, right?
It gets evaluated to become 9.
And so it doesn't loop, right? Can't loop anymore?
Oh no, it keeps going. This goes on infinitely, the loop.
If you put x inside of the parameters, though.
If you put x inside here,
Yes.
why would you do that?
Because then it would keep incrementing up.
Okay, I see what you're saying. We kind of want to avoid that because then we have to talk about pointers, which are really complicated, and we don't want to do that. What's actually happening though, right here, is you're passing undefined the first time. Because int x, yes, this is reserving space for a variable int, but we haven't assigned it a value. So we're really, technically it implicitly assigns 0, so it's going to go 0 into here, and it's going to add 1, it's going to be 1, and then come back down here, and Well, I suppose we don't have to talk about pointers then, do we? No. Okay, that's good. So yeah, it will keep adding up and up and up. So it'll come down here, it's a 1 now, right? Back up here, but won't this be an error? Would it, Derek? Because can we just call it over and over and over again?
Declare it in your setup. Win. There you go.
That's it. But if we declare in the setup, the scope is wrong, so it can't access it from the loop.
It's Arduino. What kind of scope is it?
It matters.
Okay.
Scope is important, which is probably a good time to talk about it anyways. If I declared something way up here, it's not inside of any body of any function. Byte a equal to 13. I can access this variable. Let's not call it a. That's a bad idea. Z. I can access this variable from inside this function, and anywhere else in the program. This is what's called a global variable. Because we didn't define it inside of any particular scope, it's going to be able to, you can access it from any of these functions, anywhere in the program. Yes, sir?
Define scope.
Scope? Scope is the term it's kind of a shorthand for what's called lexically scoped. And what that means is, how do I explain it? It's pretty much just an area to where the value can be seen. Does that make sense? Where can the variable be seen by the program?
Globally, basically, just right there.
This one, yes, is globally. Now let's say I defined a variable in here. Let's call it something unique. Derek is unique. And Derek is 87. I defined Derek in here, right? And let's say I wanted to add 1 to Derek. So I came down here and said, Derek plus plus. Is this going to work? From the opening of this brace to the close of this brace, this is one scope.
Okay.
And we define this variable inside of this scope, right?
Okay.
Now we're coming down here and trying to access this variable that was declared in another scope, and we're trying to add 1 to it.
All right.
The language isn't actually going to let us do this. This is an error. Because it was defined in this scope, and this scope is not inside of this scope, it's completely independent, it's all on its own out here, it's not going to be able to access it. So a scope, simply put, is really just a set of braces. So from the beginning of here to the end of here, this is one scope.
All right.
Now what lexically scoped means is if I were to make a while loop inside this function, while 1, what this means is I have a scope inside of the scope, right?
Mm-hmm.
So this is one scope, and this is a scope inside of here. If I create a variable, again, byte Derek,